All right, welcome back. Today we're going to go over a couple questions from the Chapter 1 assignment, specifically the ones listed here. If you have any additional questions, feel free to message me or email me, and we can get those taken care of. But we're going to start with those today. Okay, I'm going to go over this in sort of real time here and show you how I would draw this and etc. So if you already got this question, feel free to skip a little bit to the ones you need help with. So first of all, number 8. After a power outage, Jacob helps his mother by shining a flashlight beam at the breaker panel while she locates the trip breakers. His flashlight projects through an angle of 15 degrees, while his mother's projects light through an angle of 30. So basically we have Jacob and his mother, and Jacob's flashlight, if he's holding it and he shines it, this is the flashlight, he shines it, it's going to project through 15 degrees, while his mother's, down here, will project through 30. Okay, so right away we can see these numbers are double, right? So we're going to have to use inscribed and central angles at some point. It says, use a diagram to show a good place for Jacob to stand so that his flashlight will illuminate the same area of the breaker panel as his mother's flashlight does. Okay, so in this unit, our clue is we're going to need to draw a circle. So draw a circle the best we can. Make mine big here so we can see it. And then label roughly where we think the center is. Okay, you do not need a protractor or to actually measure these angles. We just want to understand the relationship between them. Okay, so here's the breaker panel, right? Here's the mother, and because hers is 30, which is 2 times 15, right? We know the central angle is twice the inscribed. So if the mother stands here, let's say her angle here is going to be 30 degrees, and that's going to illuminate this whole breaker panel. So the question's saying, where is Jacob going to stand? Because his flashlight is only 15. Well, he can actually stand anywhere along this circle, right? Because an inscribed angle that has the same arc as the central angle will be half. So let's say Jacob stands here on this point, right? His flashlight, because it's only 15, will illuminate that same thing. He can stand directly across. He can stand way over here. Basically, any one of these things is right. The important thing is that this arc is the same, right? Forgive this as it got a little messy here, but as long as he stands at any one of these points along the outside of the circle, his flashlight will illuminate this same area as his mother's. Okay, so that was maybe worded a little bit questionably, but we wanted you to notice this is the 2 times reference, right? 15 is half of 30. So how is it going to be set up using what we know about central and inscribed angles? Okay, let's try a similar one. It says, for a high school drama production, 3 spotlights are positioned on an arc at the back of the theater, just above the audience. Each spotlight projects light through an angle of 22 degrees and fills the rectangular front of the stage. Use a diagram to identify an ideal location to take a photo of the performance using a camera with a lens that has a field of view of 44. So right away we see 22, we see 44. We're going to have to do something similar to the last question. Okay, so let's get this set up here. So we're going to draw a circle again. Okay, we have 3 spotlights. So it doesn't really matter, right? But we know they're at an arc at the back of the room. And this is the center of the room here. Okay, so we have 3 spotlights, and they are going to obviously project some light. So if this is the stage at the front, okay, the spotlights are projecting light onto that stage. So we want to draw something like this, right? The stage is not super important in how like far it goes either way. The most important thing, as we know, is we're dealing with the same arc. So this part here is the same. So basically we're going to draw all of our lights so that they reach that same arc. And you can picture it, okay? So these are the lights. And the question is, where is a camera going to be to take this photo? Okay, well, the camera has a lens with a field of view of 44. So, because we know that's double 22, right? Because all of these are 22. 22, 44 is double 22. So, to get the same amount of stage, the same arc, the camera basically would have to go in the center. So the camera is going to go, your answer is going to be the center of the circle. And so it does say just to use the diagram, so that's all we have to do. So describe that and show that you understand that the central angle is going to be double the inscribed angles. Okay? Number 10 says, in the diagram, C is the center of the circle. ABD is 38 degrees, and they've showed us that here. For each of the following questions, justify your answer. So we're just going to write the answers here, and then I'll explain why, and you can put that in your own words as you do the assignment. So what's the measure of ACD? So we have to do part A first. ACD, you can see, is this angle here. Okay, so what's it going to be? It will be twice ABD, right? So the angle ACD is going to be then 76 degrees, and my reason for that, you can put this in better words, is it's 2 times the inscribed angle, right? Because it's a central angle. Okay. B, what type of triangle is ACD? So now we look at this this thing here, this triangle. What type is it? Well, it's going to have 2 sides of the same. So this side is the same length as that side because they're both radius, right? So that makes it an isosceles triangle. Isosceles triangle. And that means that 2 sides are the same. Okay? And that also means that 2 angles are the same. So that's what we're going to do for this last part. Part C, what is the measure of angle CAD? Okay, so if I just erase this just so we can see a little better. CAD is that angle here. Let's see if we can highlight that. Angle CAD. So we're trying to find that. So we have to play around a little bit here. So we know that all the angles in a triangle have to add to 180 degrees, right? That's true for every single triangle. So let's just draw this triangle a little bit bigger here, and then we can see what we know. So this is our triangle ACD, and we already figured out that this is 76, right? From this question here. So because these 2 sides are the same, we know these 2 angles have to be the same. So I'm going to do a quick little bit of math here. 180 minus 76 gives me 104. Because if I take away this 76 degrees, they all have to add up to 180. So I have 104 degrees left over for this angle and this angle. And because it's an isosceles, we know that the angle is the same. So we're going to divide that by 2. Divided by 2 is 52 degrees. So each one of these angles here is going to be 52 degrees. And if we add that all up, 52 plus 52 plus 76, we'll get 180. So we know we're right. So our answer, what is the measure of CAD? So it's specifically asking for this angle here, right? And if we look at our original question, this angle, that would be 52 degrees. All right, let's move on. Number 11 says point C is the center of the circle, and CFE is 25 degrees, and it shows a little diagram there. Justify your answers to each of the following. So, same idea. Let's go through it here. The measure of angle ECF. Okay, so we'll look at that. ECF, so we're trying to find this angle here. what's the measure of that? Let me think for a second here. So this will work very similar to the last question. So we have an isosceles triangle. Okay, and we know that because we have a radius here, we have a radius here. So that means that this angle is also going to be 25 degrees. So if we zoom out a little bit, we have a triangle that looks like this. Okay, we have 25, we have 25, and then we have this angle we're trying to find. So same logic. So 25 plus 25 is 50. So we're going to go 180, because all angles in a triangle add up to 180, minus 50 gives me 130. So this central angle here is going to be 130 degrees. Okay, what is the measure of EGF? So now we're trying to find this angle, EGF. Well, now we have the central angle that we just found, 130. We have this inscribed angle, so it's going to be half of 130. So to find angle EGF, we're going to go 130 divided by 2 gives us 65 degrees. And the reasoning for that is, again, it's going to be your reasoning for so many of these questions, that your inscribed is half of the central. Okay, so this sort of weird thing about this question was you needed to notice again this triangle, right? And the triangle, because these are both radii, we know that these angles had to be the same, and then we also know that all angles in the triangle add up to 180. So as soon as you know two angles, you can actually then find the third one by subtracting it. Okay? All right, hopefully that makes sense. Number 12, another request here. So it says if KJM is 15, JML is 24, and point C is at the center of the circle, what is the measure of each of the following angles? Okay, so we're going to do them one at a time, and I want to point out as well that none of these lines actually pass through the center, right? They're intentionally not passing right through, which is why, and that sort of comes in as a piece of important information, not in this question necessarily, but in future questions, we have to be careful, because just because it looks like it passes through the center, it may not always do that. So let's look at A first. So KLM. So KLM. So start at K, go to L, go to M. So it's this angle here. And then we're asking how much is it? Well, it has to be the same as this guy, right? Because they share the same arc. So basically we have some angles going this way, and we have some angles going this way, and as long as they have the same arc, they're going to be the same. So for A, KLM is going to also equal 15 degrees, because the way to say it is they're subtended by the same arc. Okay, I'll just get rid of this so we can see it a little better. Okay, B, JKL. So now we're starting at JKL, so we're going this way, and we can see that that then has to be the same as that angle because they have the same arc on this side. So that is going to be JKL is equal to 24 degrees. Okay, all right, now let's move on here. Part C is asking for angle JCL. Now, this angle isn't really drawn for us, right? Because nothing is actually going through C. So we have to do a little sketch ourselves here. So JCL. So if I start at J, go right to the center, go right to L, and hopefully you can draw that a little better on an actual piece of paper, right? We see which ones is this related to? Well, it's again related to this angle, right? They have the same arc, except this one is the inscribed angle, and this one is the central. So it's going to be 2 times 24, which gives us 48 degrees because of that central inscribed relationship. All right, and then the last one is asking for angle KCM. And so again, nothing's actually going to C, so we're going to have to draw it here. So KCM, and we're trying to find this angle. So it's going to be twice 15, right? Because they're sharing this arc on this side. So these ones have an arc on the right side, these ones have an arc on the left side, and that's how we figure out sort of the relationships between them. So it's going to be 2 times 15, and that gives me 30 degrees. So sometimes these circles will look complicated, and as you can see here, the KM arc didn't have much to do with the JL arc, right? This could have been 2 completely different questions, but it just was getting us to be able to look at them one at a time. All right, number 16. It says design a geometry question. So basically, this is very open to interpretation here, involving a given central angle for which the answer is an inscribed angle measuring 30 degrees. Include a diagram. So that's the most important part. You can be as creative or as not creative as you want. Or let's just do a super basic one. So your geometry question could be, right, obviously you need a circle. It's probably best if we include the center. And we need an inscribed angle measuring 30 degrees to be our answer. So the answer is an inscribed angle. So that means we need to do something like this. So we need to give them a central angle of 60, and then we need to give them an inscribed angle that has the same arc. So it could be something as easy as directly across. And then the question could say, find x. Ideally, we would label these, let's say, A, X, B, and then the proper way to do this would be find the measurement of angle AX, AXB. That's it. You could have a question about lights, you could have a question about photography, but as long as you have a diagram and something like this, that's good enough. So don't let that question bother you too much. Okay, and I think the last one here for now, a circle with center C has a diameter AB. So let me just take a second. We'll just draw this together. So we have a circle. Okay, and it has a center C, and it has a diameter AB. So the diameter is going to be directly across, something like this, and it's AB. Okay, so for these kind of questions where it's not drawn for you, just sort of do it one step at a time as they ask, and then go back and make sure you didn't miss anything. So it has center C, diameter AB. Done. The inscribed angle ADE measures 14 degrees. Okay, so we have no information about D, right? We don't know anything about that yet. What are the measures of ACE and ABE? We also don't have any information about E, right? So this is completely open to interpretation. So all we know is that this measures 14. So this is what I was saying. You don't need a protractor, okay? But it's good if you kind of estimate a little bit. So it starts at A. We know it's inscribed, so it has to go all the way across the circle. So let's say like this. And it has to come back, and it's going to be 14. It doesn't necessarily say it's going through the center or anything. So let's just draw it like that. And this is 14. And then what we did here was we defined some other points. So A, that means this is D, and this is E. Okay, so all the question said was it had to start at A, and it was 14 degrees. Let me just tidy this up a little bit here. So this is 14. Okay, what are the measures of ACE and ABE? So let's use a different color. If we go at A, now we're going directly to C, and back to E. Okay, without even drawing this question, you could see that ACE shares the same arc as ADE, right? Except one goes to the center. So this has to be what? If they share this same arc, it has to be double 14. So angle ACE is 28 degrees. And I'll put the reasoning, it's 2 times the inscribed angle. Okay, ABE. Now we start at A again. Let's use a different color. We'll start at A again. We have to end at E, and this time we're going to go all the way across. So the diameter, right, directly across to B, and then back to E. So just looking at this, we know that it has to also be 14, right? Because they share the same arc. They're both inscribed. So angle ABE, angle AB, is 14 degrees. And because it has to be the same, they share the same arc. You can explain that in your own words there. All right, and I think that is it. So again, hopefully this is helpful. Let me know if you have any questions. If you do need anything else specific, feel free to message me, and hope this helped. Good luck.